Oh, hi, this is Isae, your math, history, and science reporter, bringing you
The TNB Minute. Age. How old is the universe? Is it young, thousands? Or is it old, millions? Or is it really old, billions? Today, let's look at red and blue supergiant stars. Hold it! Cut! What are we trying to do here anyway? Here's an analogy, one way to describe it. Have you ever noticed how geese fly in a V, and that one side of the V is usually longer than the other side? Do you know why that is? It's because there's more geese on that side. The real trick is looking up and noticing the geese. Well, that's what these videos are like. These videos try to draw attention to things that seem to be going unnoticed. Okay, back to red supergiant and blue supergiant stars. This is the Pleiades cluster. Why are they called supergiants? Well, here's the size of our sun compared to a blue supergiant Rigel and the red supergiant Betelgeuse. Where are they? Well, there's two just to the left of Orion, and there's three near Orion in Rigel, Sirius, and the Pleiades cluster. Why are they different colors? Well, red stars are the coolest. For example, the edge of this flame is red. That's the coolest part of the flame. The yellow flame is hotter, and it's in the middle. And blue is the hottest. You can't even see it down here way at the base of this campfire. Here's another example of why they're different colors. Blue is the hottest. A blowtorch gives a blue flame and burns a lot of fuel. A yellow flame is not nearly as hot and doesn't burn up as much fuel, and the red is the coolest, and it's just barely on the edge of this candle flame. Scientists tell us that the oldest these stars can be is about 15 million years old. Red stars are almost burned out, and they're ready to supernova, and blue stars are burning up fast. And what happens when they supernova? Boom! They blow up. They leave a mess behind. Here's one that happened back in 2002. It took 2.5 years to do this. The mess left behind is called a nebula. This is the Crab Nebula left behind from a supernova that happened almost 1,000 years ago. Here's a larger view. Granted, there's a lot we don't know about the formation and lifetime of stars. But if these stars are less than 15 million years old and everything else is 300 times older, there are some big questions. If 4.5 billion years is like 1 year, or 365 days, then it's as if these stars are 1 day old. So if time began on New Year's Day and it's Christmas Day now, then these stars appeared for the first time last night on Christmas Eve. Did Santa bring the stars with the presents? If that's the case, did none form for the first 361 days? Because the day after Christmas, these stars would burn out, leave a mess, and new ones would form. And this would have happened every day this year. They'd form, burn up, and burn out, leaving behind a bunch of dead Christmas trees. I ask this because there aren't enough leftovers unless somebody is sweeping them up. Where are the ones being formed? Why are they whole and not being formed? If they were formed in the beginning, why are there any red or blue stars now? They should have all been burned up 300 times over by now. How many nebulas should we see? Well, if everything is less than 10,000 years, we'd see a few, but if everything were billions of years old, we should see a lot more leftover nebulas in the sky. We see a few according to today's rates we would expect to see if everything is less than 10,000 years old. There aren't really enough for everything to be really old. This means the Earth and the universe are not really old, billions they can't be. And they can't even be tens of millions of years old. This means that the Earth is more likely the age the Bible says, young, less than 10,000.
And that's today's lesson in astronomy.
Thank you, and remember, you matter.